In today's note, we are going to look at determining an equation or a rule from looking at a graph. Before we get into that though, I just want to go over some review questions just to help us stay up to date or keep us familiar with some of the concepts that we've learned in the past that we may not be really covering right now with these lessons. So just to kind of keep you familiar with what we've looked at. So the first example I want to look at is what is the value of the expression x squared when x equals 4 over 5. So basically what I'm trying to do is I have an expression here and I know a value that x equals and I want to solve that or basically figure out what does it equal. So if I have x squared, basically what it's telling me to do is take this value for x and substitute it into the equation. So the x is going to be replaced with 4 over 5 and that square is still going to stay there. The next thing I'm going to do now is basically just go through and solve this. So you could think of it as 4 over 5 times 4 over 5 because the squared means the number multiplied by itself or the base multiplied by itself twice. So in this case 4 over 5 times 4 over 5. Or you could represent it as because this entire thing is squared, each part is going to be squared. Either way you think of it, you still will get the same answer in the end. So 4 squared or 4 times 4 is 16 over 5 squared or 5 times 5, which is 25. And from there we can see that our correct answer is D. As well, right off the bat, as long as you knew or recognized what squaring meant and that it was a number times itself, you could cross off A and B right away because those are the only two where we're not multiplying one of our values by itself, right? We're multiplying 4 by 2 to get to 8 or 5 by 2 to get to 10. Right? So as long as you understand what squaring is, you can at least cross off the first two. And then you're left with 50-50, and then you have to think, well, does it apply to just the top number or to both the top and the bottom? And again, when we multiply fractions, we multiply both the top and the bottom, so that would cancel out C and leave us with our answer of D. So you could reason through this without actually going through and solving to find the final answer. Of course, finding the answer always helps though, because then you know exactly what it is. The next one is consider the expression below, 3x squared times 5x minus 2x plus 1, all in brackets. Which of the following is equivalent to this expression? So what we have to do is we have to take our distributive property, or that multiplier of 3x squared, and multiply it to everything inside the bracket. So remember, that's what the distributive property meant. Take that multiplier, that number in front of the bracket, and multiply it to every term inside the bracket. So right off the bat, we can see by looking at a couple of our answers, if I look at the last two terms, the minus 2x plus 1 in A and minus 2x plus 1 in C, that's the exact same as minus 2x plus 1 in the original expression. So as long as you know what the distributive property means, and that you have to multiply those two final terms by a number, we can right off the bat cancel out A and C, because we know that if we multiply, there has to be some change, right? Or as long as you recognize that you have to do something with that 3x squared to everything on the inside, there has to be some change. And in A and C, there was no change for two of those values, so it can't be that. I'm going to rewrite my question now, and I'm going to start to solve. So again, we should remember that we have to use distributive property, which means we have to multiply the outside term by everything on the inside. So 3x squared times 5x squared, well, 3 times 5 is 15, and then x squared times x squared. If we just look up here, we have x squared, or x times x squared again. And we have 4x's together, so basically that's x to the power of 4, or you could also use your power rule. So right off the bat, by doing the first calculation, I can already see that my final answer is going to be D, because this is the only one that has 15x to the power of 4. It's not going to be b, because b has 8x squared, which does not match up. Right? So they're trying to trick you. If you thought that all you had to do was add your numbers, that is where they would get you. But as long as you remember distributive property, or at least understand that the operation is multiplication, you're multiplying that 3x squared through. If we do the next one, 3 times negative 2 is negative 6. X squared times an x is 3x's, or x cubed, or x to the power of 3. And then 3x squared times 1 is just 3x squared. So there, right off there, we can see fully that our answer is exactly D. So these are just some tips or some ways, or just some examples of multiple choice questions, and just some kind of tips of going through and how to solve. Right? The main idea is to try to eliminate some of the answers first, and then start your solving or your operations, and then hopefully you can start to eliminate some, and you may even be able to eliminate them before you get into any of the actual, or before you get to a final solution. You may be able to get the answer by doing one thing. So what we're going to look at today is determining a rule from a graph. So we have two graphs here, and I want to determine what is the rule from the graph in the form y equals mx plus b. So if we're talking about a rule, we want basically the rule or the equation, and we should remember from previous lessons that it's in the form y equals mx plus b. Remember, our m is our multiplier, or you can also call that the slope or the rate of change. And then our b value is our y-intercept, or our starting value, or initial value, whatever you want to call it. So let's start by looking at the first graph on the left here. We can see the number of tiles on the y and the position number on the x. First thing I want to do is I want to come up with a table of values to help me visualize what these actual numbers are. Okay, I need an x and a y, and I'm going to pick 4 points. Because they form a straight line, you don't need to choose all the points, because you can get the answer from just a few points as well. Realistically, you really only need to have 2 points. I'm just going to choose 4 so we can see the pattern a little bit easier. So the first one, the x value is 0, the y is 2. Then we have 1 and 4, 2 and 6, 3 and 8. So there is my table of values. The first thing I need to do is find my m value, or my multiplier. And we're going to add some new terminology here. The m is the change in y over the change in x. So in this case, if I look at my table, the y value is changing by 2 every time. It's increasing by 2, so plus 2. And the x value is increasing by 1 every time. So the bottom number of my fraction is 1, or this can just simplify to 2. So this new terminology is going to help make it easier if we have x values that are not increasing by 1 every time. The last thing I need to do is find my b value, and there's 2 ways we can do this. B value, or the y-intercept, we know is when x equals 0. So there x equals 0 and the y value is 2. We can also look at the graph and see where does the line cross the y-axis. In this case, it crosses at 2. So my b value is 2. Now I have my m and my b, so all I need to do is just plug that into my equation, or my rule. So y equals 2x plus 2 is the rule for the first graph. For the second graph, I'm still going to do the same thing. So there's no difference in the steps, although our answer may be different. I'm going to pick 4 points and plug those into a table. So 0, 0, 1, 2, 2, 4, and 3 and 6. I want to find my m value, or the change in y over the change in x, and I'm going to go through and find that from my table. So I can see that the y values are increasing by 2 every time, 0 to 2, 2 to 4, 4 to 6, increasing by 2, and the x values are increasing by 1, 0 to 1, 1 to 2, 2 to 3. So my change in y is 2, my change in x is 1, so I still get a slope, or an m, or a multiplier of 2. For the b value, again, same idea. Where does it cross the y-axis? So going down my line, that's where it crosses, and the value that it crosses at is 0. Oops. I could also look at my table. When x equals 0, what does y equal? Well, y equals 0 as well, so my b is 0. I can put this all together now. So y equals m, or 2, x, and I could throw in plus 0, but because when I add 0, nothing changes, I don't need to show it. So my equation is just going to be y equals 2x. And that is my equation, or rule, for the second graph. So just looking at these two graphs, what is the same, what is different? Well, looking at the two graphs, or the two equations, or the two rules, they have the same slope of 2, and what is different is they have different y-intercepts. Different y-intercepts, or different starting values, or different b values, same terminology, or different terminology, same concept. So just to summarize what we did, to determine a rule from a graph, we need to find two things. And the two things we need to find, one is our m value, which is the slope of the graph, multiplier, or rate of change. And we've talked about some new terminology. It's also the change in y over the change in x. Or another way we can refer to it as rise over run. So rise refers to how much up or down you've gone, and run refers to how far left or right you've gone. Right? Because you run left and right, you rise up and down. Lastly, we also need the b value, or the y-intercept of the graph, which is also called the constant, or the starting value. Another term, initial value, will sometimes get thrown in there. And those are the two things that we need to come up with a rule. To find the slope, so to find a slope, we talked about basically we need to find at least 2 points on the graph that are on whole number values. And that's a key thing. We want to find where they cross nicely on the grid, or basically where they have nice whole numbers, so that it's easier to calculate. We can then put these numbers into a table of values, determine the change in y and the change in x, and there we have our formula. M is equal to change in y over, or divided by, the change in x. And that's how we find our slope, or our m value. To find the y-intercept, this is a lot easier. Basically, you're just trying to determine the value of y at the place where the line crosses the y-axis. So again, you're going to go to the y-axis, or the vertical axis, and just see where does the line cross, and look for the value of y. In other words, what you're doing is where x equals 0, what is the y value? So that's just another way of asking or saying what you're actually doing. You're looking for where does x equal 0 and what is that y value. And again, the b, that's the y-intercept. which is the b value in the equation. So taking that idea, what we're going to do now is come up with a rule that represents this line that we see here. So the first thing we want to do for 1, and I'm going to bring it down here just to have a little bit more room, I need to pick a couple points. I'll pick 4 points again just to kind of keep it similar, but I'll show you how you can really do it with only a couple. So we're going to have our x and our y. I'm going to write in my points, so 0 and 3, 1 and 6, 2 and 9, and 3 and 12. So here I have to find my change in y and my change in x because I'm looking for slope. So I need to see what does the y go up by and what does the x go up by. So if I look at each individual point, well, from 3 to 6, I'm increasing by 3. 6 to 9, I'm increasing by 3. 9 to 12, I'm increasing by 3. So my change in y is going to equal 3. To look at the change in x, 0 to 1 is plus 1. 1 to 2 is plus 1. 2 to 3 is plus 1 as well. So again, that's going to be 3 over 1 because the change in x is plus 1, which is 3. Now, I did mention that you could only use 2 points at the very least if you wanted to. And we can see that if I use the first 2 values, or the first 2 points, I would already see the change in y and the change in x. If I had 2 points that were spread out a bit more, let's say I was looking at these two, from the first point and the last point that I picked, from 3 to 12, that's a change of plus 9. And if I look at the other side for the x, from 0 to 3, that's a change of plus 3. So if I wanted to, change in y from those two points is 9 over the change in x in those 2 points, which is 3. 9 over 3 is the same thing as 3. So there's different ways you can do it. You don't always need to choose the 2 points or choose 4 points. You could choose 2 points that are right next to each other. You could choose any 2 points, and as long as you look for what does the y values change by and what do the x values change by, you can figure out the slope. Lastly, for that b value, you want to see, okay, where does my line cross the y-axis? So again, if it's easier, just draw a line right down the y. See where do we hit our line. We can see that we hit it there. We can also see that it is when x equals 0 in our table. So our b value is 3. So in this case, the equation or the rule that represents this line is y equals 3x from my m and then plus 3 from my b value. For 2 asks what rule would have a line that has the same y-intercept but a different steepness or slope. So here there's lots of different options because the main thing that you're looking for is the same y-intercept. So if I wanted to come up with a rule, I could do y equals, I know it has to have the same y-intercept, so I know it has to be plus 3. And there are different things that you can do. So if it had a different steepness, that means it could be steeper or shallower. So if it was steeper, we need to pick a number that is higher than 3. So we could say 7 would be our new m value, and that would work. Or you could do something different. We still are going to have that plus 3 at the end, but say we wanted it to be shallower or less steep, so we would pick a number less than 3, so we could say 2. So y equals 2x plus 3. So that also works as well. So again, as long as you're just changing the m value, it would be a different rule. You just have to keep the b value the same. let's actually just, so that b value has to stay the same from that original equation. Number 3, what would happen to the line on the graph above if the rule changed to y equals 5x plus 4? So that's what we're changing it to, and we want to see, okay, what would happen to our graph if we change this? And we have 3 options. The line would start higher on the y-axis, the line would be steeper, the line would start higher on the y-axis and be steeper. So we want to look at the two and kind of compare them, and we should be able to see, well, the initial value of 4 is going to start a little bit higher. So we're going to start 1 higher, right, because the last one had a 3. And then if I'm increasing by 5, right, or my change is 5, so the change in y is 5, the change in x would have to be 1. That means every time I go over to 1, so I start at 4, I would increase by 5, which would take me to 9. Position 2, increase by 5, which would take me to 13. Oh, sorry, 14. Position number 3 would increase again by 5, so that would take me to 19. If I wanted to draw my line, if I can draw a straight line, put number 3. So that would be my line for number 3. So how would that graph change, or how would this graph look? Well, we can see that it does start higher on the y-axis, and it is steeper, so it's increasing faster, or it's getting taller faster. So that would be the final option. So line would be higher on the y-axis and be steeper. Another way you could get to that is you can see by looking at the equation that we've changed 2 things. The 5, or the m, has changed, and the b, or the y-intercept, has changed. So that means there should be 2 changes in our graph. So it can't be the first one because that's only 1 change. It can't be the second one because that's only 1 change as well. So that only leaves us with the third option. But by actually plotting those values down, we can see that it actually is both starting higher and being steeper. So again, the main thing from this note is being able to understand how to come up with a rule from a graph. So that's using a table of values to help you figure out the multiplier, or the m, which is the change in y over the change in x, and being able to recognize where is the b value or the y-intercept.